One goal of this course is to get you thinking about different ways to model data in Redis. In this unit, we're going to look at a DAO implementation for solar site metrics that uses sorted sets. The DAO will allow us to represent the minute-level meter readings coming in from our devices in the field. We'll consider the pros and cons of using sorted sets for this problem. And in a later unit, we'll try modeling the same data with Redis time series. Let's start with the abstract base class for the DAO. As you can see, we need to implement two methods. One for inserting a meter reading, and another for getting a recent set of measurements for a given metric unit. The big question is, how in Redis do we store these meter readings? Let's do some whiteboarding to find out. What we need is a way to store lots of metrics in a single key, and we need to be able to query ranges of those metrics from within that key. Sorted sets are a good fit for this. Let's see why. The idea is to store all minute-level meter readings for a given day in a single sorted set. That would look like this. First, we need to define the key we're going to use. Let's say metric : followed by the metric name, so in this case, WHG for watt hours generated, followed by the day, so January 1st, 2020. And then we add the site ID, in this case, site number 1. Now, what's in the sorted set? This part is a bit tricky because we need to work around the fact that the sorted set is still a set, so its members are unique. For the score, we store the minute of the day. This will allow us to sort the values by time. But for the set element value, we run into a challenge. Let me show you why. Here's our sorted set. Now suppose at minute 0, we record a temperature of 18 degrees. Then at minute 1, we record a temp of 18.5 degrees. So far, so good. The problem occurs when, at a later minute, we record a temperature of 18 degrees again. Because a sorted set is a set, it's going to see that it already contains this new element. That is, it's already seen 18. So we'll update the score and position of the element. So this happens. Now 18 is associated with minute 300, and minute 0 has no associated measurement. Well, that's not going to work. So we have to be a little crafty. We need to find a way to ensure that each measurement, that is, each set element, is unique. Recall that these sorted sets will contain one measurement per minute, numbered 0 through 1,439. That is, there are 1,440 minutes in a day, and we use a zero-based index. So what we're going to do is append the minute number to the measurement value, joining the two with a colon, like this. That gets us what we want. Now we won't have to worry about having duplicate elements in the set. So in the end, our sorted set looks something like this. Each sorted set contains all the values from a single metric for a given day. As you can see here, the scores represent each minute within the day. The elements of this set are strings containing a measurement plus a colon plus the minute number. This ensures that each set value is unique. So what are the advantages of this metrics storage model? Well, one is that measurements we care about are always sorted. This is important because measurements may sometimes arrive out of order, and we need these elements to be sorted when we display them in a chart. Two is that we can efficiently fetch any range of values within a day. If we just want entries for a particular hour, the zrange family of commands can achieve this for us, and it can do so in roughly O log n time, plus OM, where m is the number of elements we're retrieving. 3 is that inserts are relatively cheap. The time complexity for the zadd command is O log n. So even for a sorted set containing thousands of entries, there will only be a handful of operations that have to be performed to complete the insert. Finally, using a sorted set allows us to store a lot of elements using a single Redis key, which saves memory. Now there are two small potential downsides to using a sorted set to store metrics. The first is that the sorted set elements have some extra, unneeded information in them, which we need to clean up on the application side. The second is that more than one metric for a single minute could conceivably be recorded. This will be true if a device somehow reports two different measurements for the same minute. If this is a problem for your use cases, there are some ways to mitigate this. You might do that through rate limiting, discussed in week 4 of this course, or try keeping track of which minutes have already been recorded using a set. Or you might model the data as a time series with the Redis time series module, which we'll discuss in week 4. Hit us up on the course forums if you have further questions about this. So in this unit, we looked at how to model site metrics as a Redis sorted set. We analyzed the performance of this approach and considered some downsides. In the next unit, we'll continue with our sorted set metrics implementation.